السلام عليكم ورحمة الله وبركاته بناتي وأولادي. النهاردة إن شاء الله بنستكمل مع بعض the set of rational numbers اللي اتكلمنا عنها. قلنا natural numbers، integer numbers، بعدين rational numbers، وإيه هي شروطها؟ يكون الفراكشن enumerator عدد integer، denominator number integer، ولكن ال denominator non-equal to 0. Today we shall complete that part. This is the continuous, this is lesson number 1. Continuous of the set of rational numbers. وكان السيمبل بتاعها كان Q. The set of rational numbers اللي هي set Q. الحقيقة احنا عندنا النهارده some points عايزين نتكلم مع بعض. First of all, we shall talk about the recurring decimal. ايه هو recurring؟ The recurring fraction. ايه هو recurring fraction؟ بنات for example أولادي for example لو أنا عندي 1 divided 3 أو 2 over 11. لو عملنا long division 1 divided 3 أو use the calculator هتكتشفوا فورا إن الأنسر it will be 0.3333 إلى ما لا نهاية up to infinity. إحنا اختصارا بنكتبها 0.3 وبنيجي فوق الجزء اللي عمال يعني repeated up to infinity ونحط فوق منه point. يبقى point معناها البارت اللي repeated up to infinity. Also لو جينا عملنا long division ل 2 over 11 أو we can use the calculator. The answer it will be this decimal. If it is negative for example it will be also negative. وعشان النيوميريتور أصغر من denominator smaller so it's 0 point. هنكتشف حاجة غريبة أوي. It will be 18 18 18 وهكذا up to infinity. So we can symbolize it at 0.18 18 18 وهكذا up to infinity. So it will be 182 points like this. Sometimes بعض البوكس ممكن تكتبها كده 0.18 وفوق منها بار بنقول عليها بار أو يعني زي شرط طويلة شوية تشمل ال 2 decimal points. طبعا المنظر ده لو جالي I can write it as a fraction وهكذا المنظر ده I can write it as a fraction. Okay. This is the recurring decimal and this is also اللي أنا يهمني في البوينت دي. ليه أنا بدرسه؟ أنا بدرسه علشان ال 2 decimals دول this is a fraction. It's rational. Also this is rational. So this is belonging to the set of rational. وبرضه المنظر ده also belonging to the set of rational. سواء ده أو ده. So we can say that this fraction can be written as a recurring decimal and it is belonging to the set of rational numbers. Also this one is belonging to the set of rational numbers. We have some problems. A problem. Let us see this problem together. He says that in this problem, use the number line to identify the additive inverse. So, use the number line to identify يعني to recognize about the في point يعني في حاجة اسمها كاتبها في البوك opposite غلط opposite number. لا هي غلط كلمة opposite. مفيش حاجة اسمها opposite في الماث. في حاجة اسمها additive inverse، حاجة اسمها multiplicative inverse والاثنين opposite لنمبر. يعني الكلمة دي مش صح. كلمة opposite في الكتاب it's not correct in science أو in mathematics. Is the additive inverse. Additive inverse. كانت الترجمة غلط في الكتاب يعني. Additive inverse of each of the following. And he gives us like this. you have a straight line like this. Let me arrange them as a book. You have here, yes, 1, 2, 3, 4, equidistant. Equidistant. Yeah. This is decreasing direction. This is increasing up to infinity. This is -2. This is, I don't know. This is -4 over 3. This is -1. And this is, I don't know. And this is -1/3. This is 0. This is 2 over 3. I can extend it a little. Extend it a little here. 0. What is it? Sorry. -2. Okay. 2 over 3, -1 over 3. 0. They are not equidistant. They are not equidistant. Let me make it the distance correctly. Like this. See? I'm sorry. I'll rewrite it again. 1. -2. -1. 0. 1. Okay. This is -2, -1, 0, 1. Each part between -2 and is divided into 3 parts. Also 3 parts. Also 3 parts. And also and on. We have here a space. I need this space. This is -4 over 3. This is -2 over 3. This is not this one. This is 1 over 3. 1 over 3 with a negative. This is a space. This is 2 over 3. This is 1, and this is 4 over 3. I need to find out this, and I need this, and I need this. How can we find them? The denominator, all of it is over 3. Look, I will write here something good. Look at 0. Denominator is usually 3. This one, it is 0 over 3. It is 0 over 3. This is -1 over 3. This is -1 over 3, so -2 over 3. This is one complete whole number, so it is -3 over 3. This is -4 over 3, so this is -5 over 3. And that one is -6 over 3 is 2 with negative. 0. 2 over 3, so this one is 1 over 3. This is 3 over 3. 4 over 3. This one, it will be 5 over 3. That's all. Now we completed the scale or the straight line or the number line. I want for me to complete now. Make a complete. I take one of this. Or I want to make now comparison. Now we shall compare. Now we are comparing. Comparing the rational and ordering. And ordering. Ordering means arrangement. Ordering. Rational numbers. Rational numbers. our number. Comparing and ordering rational number. Listen to me. I have an important rule. What is it, the rule? What is the rule? The rule is, if you draw the straight line like this, this is a rule, important rule. If you draw the straight line like this, you have to understand or realize that this direction here is increasing direction up to infinity. If you go back, so this direction is decreasing direction, so it is negative, so up to infinity. So this is the increasing direction, this is the decreasing direction. If you follow this rule, so you have 0 is the mother, it's the origin, 0. If you go right, as you go right, as the number increases, so if you have here, listen to me very well, positive 1, positive 2, positive 3, positive 4. Back, it will be negative 1, negative 2, negative 3, and negative 4. And so on. Also here and so on. What's the relation between those? 4, if you compare 4 with 3, so you write like this. 4 is greater than 3. Okay, if you compare 3 by 2, so 3 is greater because you go back like this. 3 is greater than 2. By the same way, so 2 greater than 1. By the same way, 1 is greater than 0. Okay. About this part, what will you write down? 0 is greater than, greater, and so on. By the same way. So 0 is greater than negative 1, greater than negative 2, greater than negative 3, up to negative infinity. Good? So as you go far on the right side, as the value increases. So look at this. Look at this. Wow, can I write it? Yes. 3 is greater than 2. Good. Look at this. Oh, yes. So, negative 2 is greater than negative 3. We have now a rule. You have a new rule now. What is it? What's the new rule? So, 3 is greater than 2. But if you put negative for both sides, it will be negative 2 is the greater. Negative 2 is the greater. So if you compare this by this, it's look like as multiplying or dividing by negative value. If you put negative, it will be like this. Try to write this here down. You can read it from here. Negative 3 is less than. So negative 3 is less than. Less than what? Negative 2. What do you notice? We notice that an important rule. Important rule. What is this rule? The rule is if A, whatever A is any value, any integer number, any rational number, is greater than B, so this implies that if you multiply your negatives, so it will be negative A, negative B. What will happen here to the direction of the sign? It will be in the opposite direction. So this greater sign, it comes smaller. For example, 7 is greater than 3. So by the same way, the same rule, so if you put negative 7 and negative 3, you have to change the sign. The greater must be smaller. Another one. Negative 5 is smaller than negative 1. Yes, negative 5 is back, more back. Negative 5 is more back. then -1 here, -5 here. So -5 is smaller than -1. This is correct. This implies that try to remove the signs or multiply both sides by negative. They become positive. So it will be +5 and +1. What can we write here? We can write here greater than. Smaller, it becomes now greater. So what happened? Look, smaller, look, greater. So this is the rule. This is an important rule. Take care about this rule. If a number is greater than other, so the additive inverse is less than the additive inverse. So the additive inverse means that change the sign. Is number to the additive inverse? I'm sorry here, I didn't tell you about additive inverse of -1/3. Its additive inverse is +1/3. Again, +2/7. Its additive inverse. Change the sign, it will be -2/7. I forgot to tell you. This is another example, number 2. I'm sorry. This need to complete that line, but this number 1 to find the additive inverse. So you see the additive inverse, if you have an equality, change the sign in the, okay. I want to rearrange. Last one, arranging. Arrange ascendingly. Ascendingly. I want to arrange. This is an example. Look, I'll give you only one problem. I want to arrange 3. I want -5/2 on the number line. 3/2 and -4. I want to arrange it. Of course, all negative are back. So this is negative, they are back. This is positive, this is positive. Which is bigger? This is 1.5, you know, 3/2 is calculated to 1.5. This is 3. I need ascending. So this is the straight line. Where is the lowest number? Lowest number or the smallest number? This is 4. This is 5/3. Of course 4 is bigger than 5 because this is 1 point. This is 4. 4 is more back. So -4 is here. Then little back here, -5/3. Don't mix, still not me. And then 3/2. Last one is the bigger one, is 3, because this direction of the increasing direction. Enough today. I'll complete next time, inshallah, about the arrangement and how to represent the number line, these points. Representation means you make point like this, point like this, point like this, and like this. That is. I need from you this homework, please. I need from you this homework. Okay, exercise. Page 14. I need from you from number 1 to number 4. Thank you very much. See you next time. Please try to work day by day. Don't leave mathematics any day. Thank you and goodbye.